Good evening, ladies and gentlemen. Thank you very much for giving me a voice. Today, I will be talking about anaerobic digestion and potential techniques used in this case for increasing methane production. The work is published. The work, when I instead published by Bioenergy Research in May of 2023 by work by Punjab Bioenergy National Institute in the direction of Professor Kumar, and entitled is Anaerobic Digestion: Advanced Techniques for Biomethane Biogas Production as a Source of Renewable Energy. The case's initial point is that production of methane by anaerobic digestion, so transferring by organic matter, which is supposed qualified as mostly organic material into firstly acids and then methane in fully anaerobic digestion. And the case is very fine if for feed that we qualified by waste, many organic waste can be digested, and natural waste especially, and these can cover close life cycle assessment and techno-economic aspect of the anaerobic digestion process. The process is writing about 5.5556 parts: biogas pretreatment, direct interspecies electron transfer, meta yield, elite lossless feedstock, and carbon-based additives are major points of this publication. First is that sometimes some is to requirements will rise by 21, and scenario with 35 decrease of energy by reducing of oxygen is it was appointed by India and China in Paris announcement from 2017 16, and this would allow to limit using and reduce using wind energy, solar energy, and biogas for limiting use of fossil fuels. Then organic matter as food waste, agriculture waste, all terms from many of all kind of animals are a potential field of money or of potential substrate or matter, and increase the according to zero waste prognosis, the 2.1 billion of global organic waste increased for 3.4 billion waste in 2015. That makes potential big source of energy and green chemistry, and anaerobic digestion can be one of potential. There can have the hydrolysis, methanogenesis, both awaiting limiting steps during methane production as final step. Very microbes can be usually butteric methanobacteria. These different cases of bacteria are useful. And this hydraulic retention time, pH, and with solid retention time and feedstock characteristics are giving particle size is 2.5 to 8 milliliters as favor in case of food waste and digestion, and drying matter to be below 29% initial is well, and thus drying of substrate is useful. As the four processes, we have uh, process of anaerobic digestion, we have several products, process of carbohydrate, lipids, and proteins in different phase. In first is solubilization, the first part of acidocytogenesis, and volatile acids and simple molecular sugars and amino acid are transferred into volatile acid, butyric acid, and this time can produce some initial hydrogen. In acidogenesis, this acid is butyric acid and acetic acid, not only acetic acid, as here said, mostly propionic acid, and this will transfer in metagenesis into methane. The first bacteria which or fungi involved in the first process, hypolysis, are the firmicutes and asparagines, which are fungi and bacteriophytes actinobacteria, which can contain cellulose and lipase enzyme to break the long polymers into small organic matters, which is suitable for methanogenic and hydrophotrophic bacteria. And next step in acidogenesis, the important are Acidobacterium, Clostridium, and Firmicutes, some bacteriotides, and also Ruminicoccus, which is important that sulfur is hydrogen sulfide is also emitted, which is the parallel process for hydrogen production, and reducing of hydrogen sulfide is important to make high percentage natural gas without any much polluting. And hydrogen sulfide we now wanted to reduce because it's quite corrosive to our equipment. Therefore, there are these five parts. And case of pH and the alkalinity, the CPS is the most is for mass substrate is 6.8 to 7.2. However, some acidogenesis, some material that is acidic more, as for example, sorghum, for example, some some pineapple, while others, like for example sugar beet, are better in 8.5, so better in slightly hydroxide level. Then there is high proteinity and there can be temperature according to three parts acidogenic, mesophilic, which is 40 to 6 to 30 to 40 Celsius, which is uh, usually used because mostly is on Earth have moderate climate and this require less temperature. However, occurs also psychophilic 20 to 30 degrees, which is suitable for regions where it can, for would be for regions when it's very cold regions where utilization is mass, for example, high mountainous regions, and subarctic where low temperature and not would be requiring high temperature for high energy requirements. There is also some more efficient than mesophilic thermophilic, which feels well, 50 to 65, and also there are in some cases more extreme thermophilic from Vesuvius in 115, but especially the extreme thermophilic would be high temperature required for living, and some other 50 to 65 are, give much energy, but sometimes when feed is suitable and require giving much energy can be considered into design. Hydrogen retention time is going how long should stay this in reactor this feed, and mostly therefore is different for different feeds, especially for manure. It's between with mixed with straw found 10 to 15, while for only manure is 18 to between mm, 10 to 40 days. So this difference to different feed. Design is different. Some also continuous upflow reactor, and but usually two stage are performed the best at three stage or even more stages because it's similar to the stomach of ruminants, which are mostly being the we match reactors to the nature because think that is most efficient case in nature. So mimic these files. But there are upflow reactor seems to be more efficient, and two stage is enough to be quite enough efficiently, and no equipment cost much. There are some pretreatment of feedstock from chemical pretreatment by thermophilic, hydrothermophilic, and microwave uh, or thermal extrusion, ultrasonic, chemical, ionic liquids. For example, one bottle which decrease pretreatment but even one is especially good for residues for softwood and alkali assisted wet explosion, biological but very slow. This material increase much, but needs to be not some ways that is not going so fastly to be useful. There are also physical, doesn't require solvent, doesn't have other problem, increases the surface area of for micros, requires some energy more for treatment. Steam explosion method is chemical addition is not required, but cause loss of water and energy, high cost of efficient microwave radiation. Uh, they say that yields of methane is not enough to compensate for required energy, but still our works can enhance solubilization, better heating energy efficiency, the thermal method quantity. The thermal is using reduces the formation of inhibitors. This process is better for steam explosion. Water requires is very high, and inhibitor this in low temperature. So we have high temperature enough to reduce it. Chemical, there are apparatus that can be corrosive, hazardous, acid, biological are slow, and loss of cell activity require highly controlled uh, environment to not uh, reveal this microorganism to which are would be could be invasive in if sometimes. So these are the troubles and generated, and this shows as process diet transfer it has been emphasized to increase yield. The production diet can be the augmentation to increase diabetes, and mm, this is helped by using some nanowires, nanoparticles works, and these electrons uh, uh, these electrons direct interspecies electrons transfer is to some catalytical metal catalytical issue like or nanoparticles, and this is increasing by increasing by charging between electrons improvement, and this increase even in case of especially failure, in case iron oxide decrease 2 times methane, and more is nickel. Iron is given, but here they forget that this electron, these metals are mostly iron and nickel are, are stimulating enzyme hydrogenase, and more hydrogen produces more, giving to methane produce high concentration of methane, and this is mechanism which not only by this, also by enhancing the quality of enzymes. So not only energy electron transfer say, but it is say can be. This is can be also carbon and fullerene, and we see that only 30% is hard. While in case of iron oxide and nickel oxide, titanium oxide not, it helps because can one factor can be this that it increases the activity of enzymes, which forget about this. And it's important in closing cycle. So recovering from waste to energy and green chemistry cells, and there are many models for open Aspen which helps to predict and design the processes. The fixed capital and return after 5 years in independent for legal issues in some countries, and that's important of polity of government to support. Thank you very much for listening.